So, welcome, Pietro. Good afternoon again.
Hi, Francis. How are you?
I'm good. How are
So
you?
I'm fine. I'm fine. So okay. So let's start with this class on MQTT and PubSub messaging. The structure of this class is we'll have around 20 minutes, half an hour of theory with the slides. In the link that you see here, you can find all the information. And then we'll do a practical part where we will play with MQTT and this type of protocols. Okay.
Yeah, I shared your materials also before your lecture, so I think people are ready to prepare to follow you.
Okay. Perfect. So okay. So what is MQTT, or in general, what is this PubSub system? So what we are typically used to is to work on what is called REST model. So basically, which is how the web works. So basically, you do a request, and that gets to a server, and the server sends a response. So you basically input a URL, and then the web server will reply with the web page. Okay, so this is the classical way. So, but in this way we are working, there is one client and one server. You can actually have millions of clients, and they all work with the server, but they don't see each other. Okay. So with the PubSub approach, the structure is different. Okay. So we have clients, clearly, and there are clients that produce information, which are called publisher, and clients that use or receive the information, which are called the subscriber. And there is an element which is called broker, which is kind of a server, centralized server, that takes care of getting the data from the publisher and send the data to the subscribers. The other important concept is the concept of topic. Any information that you produce, that the publisher produce in this type of system, is labeled with what is called topic, which is kind of a label, like more or less the URL that you use with a web browser, to say, okay, the content of this data refers to this type of values. So, for example, you have this picture, and you see here on the left, there is this. This represents as many sensors that you want, as many input devices that you want, publishers, and they publish data with this type of topics. So there's what the word sensor, field for the type, then the country, the city, and the location. They publish all the information to a broker. Okay, all publishers send to a broker, and the broker can distribute to subscribers. So, for example, there is a subscriber that said, okay, I'm interested in data with this topic. So it's sensors, second field vibration, remember there's a type, and then this hash sign, which means whatever comes on the right. I will give you more examples. So this is, for example, an earthquake monitor application, and wants to receive all the information that has these common characteristics. And now, for example, someone in London wants to create a weather application. And so this person needs the information that of this type, sensors about temperature, about which country, UK, and about which city, London. Okay, so it's a specific topic. And then we want to create a repository, store all the data, and so we can have a client that subscribes to hash, which means everything. Okay, now, so this is the most generic topic that you can create. I will explain better the topics in a few minutes. Okay, so the basic idea, it's important. The important idea is now you don't have a client that talks with a server and the server talks back to the same client. So now you have a lot of clients creating data and as many clients as you want using that data. Okay. So this PubSub approach is not new, but is quite growing recently. There are various protocols. We will talk with detail. I will describe MQTT, but a lot of providers are adopting this approach. Here you see the links for Google Cloud. Here you see Amazon. Redis is very well used application for data sharing, very fast. You have Kafka, this kind of new PubNub, again, used to share data among many different clients. And the structure is the same. If you take a look at this picture, for example, you have a center device, which is this broker, and many clients producing information or consuming information. So I will focus on MQTT. Why MQTT? And later I will show you the code of a MQTT client for MicroPython, written in MicroPython. And you will see it takes some, I don't remember, 200 lines. And it works with the PyPy you're using, with the PyCom devices that you may be using. So the acronym is for Message Queuing Telemetry Transport. Is basically used to work with publish subscribe protocol, which is lightweight, again, a few lines of code that can run on embedded devices and on mobile platform. So it uses very low power. It can save bandwidth by compressing the binaries, the headers. And well, as a limitation, there is this 256 megabyte for message, which in general for IoT is more than enough. You can find a lot of information in these links. Some details. I mean, I think it's important, this information, just for you to understand when you see these numbers. So this is basically the current version. Actually, let's say this is the most stable version, the most widely available. The version 5.0 is becoming more and more the reference or the current version. There is nothing in between. I mean, in between 3.11 and 5.0 is basically nothing.
So that 256, is it like per time period or per year or something?
Yeah, okay, I see the question. No, this is in a single message. So a single message created by a client cannot be bigger than 256 megabytes. Okay, so don't think about LoRa and LoRaWAN. Here we are, and now I'll describe a little more. Here we are at application layer. Here we are on top of TCP. So that value represents the maximum block of information that you can send in a message. So it's not per time period. It's each time you send something. And here you see, so it's important that MQTT is on top of TCP. So it's kind of in the communication stack is kind of HTTP, is higher level. So typically below it has TCP, so it's written on top of TCP. There is a version not widely used, but it's available, which is called MQTT SN. So the SN stands for Sensor Networks. And then you also have what is called WebSockets. So WebSocket can be used if you want to develop your application directly into a web browser. And then there is the alternative to use below the secure, the secure version of the socket. So I think there are still questions about the size. So there seem, I don't know if I created confusion with the size of the packet. So what you have to imagine is clients producing information. Imagine a sensor, and it reads some value, and it produces an information, a message. Okay. And it can do that one every millisecond or every 2 days. I mean, the frequency is not important. We are not LoRaWAN with the restriction duty cycle. So if the only restriction that MQTT has is that any message cannot be bigger than 256 megabytes. I don't know if I explain now better. Okay. Okay. So hopefully yes. Okay. So let's see the interaction sequence. So as I said, you need to have a broker. Later, I will show you how to create a broker in basically 10 seconds using Docker. As if you want to know about Docker, you can take a look at the talk on Monday. And then you have publisher and subscriber. So they are both clients, okay? But typically clients can generate data or consume data. They can do both, but the typical structure is I either publish data or I use data. So in the protocol, so they need to connect, physically connect. This is not a low-level protocol. This is a high-level protocol that connects to the broker. And there is an explicit acknowledgement to the connection. So they are connected to the broker, again, on top of TCP. So it's kind of TCP link, TCP socket connection to the broker. And then the subscriber subscribes data. Again, this data can be from 1 bit to 256 megabytes. And it has to put a label saying, okay, the topic is this one. Now we will see the example, and I'm sure it will be more clear. And then this subscribe is ACK. And then when somebody publishes, it says publish topic data. And so the subscriber will receive that data. But as you see, the broker receives the information, checks for the subscriber, and publish the information. So here you can have thousands of publishers and you can have thousands of subscribers. Okay, and it's the broker that will deal with sending the proper information to the proper client. Okay, so topics. As I said, any data that you create must be labeled. Okay, and the label is what is called topic. Okay, so the topic is, again, is a sequence of names that are separate by a slash, forward slash. These are some of the rules. There must be it's case sensitive, so uppercase and lowercase is important. UTF-8, and well, okay, they must consist of at least one character, sure. And this is not, I mean, mandatory, but the structure is typically hierarchical. So, for example, if you put a lot of sensors in your house, so you can start from the higher level, which is your home, my home, and then you can say, okay, this is ground floor, then this is living room, this is temperature. So typically the topics are structured hierarchically from left to right. Okay. There is no specific topic unless with the exception of this $sys topic. Okay. And it's used from the broker to provide some control information. We will see an example in a few minutes. Okay. So the other important things about topic is this, what is called wildcards. So wildcards allows you to kind of create pattern to describe better the topic that you are interested into. So these are used by subscribers. So for example, imagine that you are interested in anything that has a first field house. So what you can do is they say house/hash, and hash means matches a whole subtree. So house/hash means, for example, this topic, this other topic, this other topic. The plus basically means anything in a field of a topic. So for example, if you say house plus main light, this covers, for example, house room 1 main light or house garage main light, because this field in the middle is indicated as, okay, whatever comes in that field. But again, it doesn't cover clearly these other two, because the third field here is side light and front light, while here it says main light. Okay, so for example, you cannot say house hash main light. Okay, if you put here a hash instead of a plus, that would be a wrong way to represent a topic, because as I said here, hash matches a whole subtree, so you don't have to put anything on the right of a hash side. And final, final, let's say, element that is relatively important is what is called quality of service. So the quality of service means it depends on the importance of your data. Again, remember that below you have TCP. So TCP is a reliable protocol. So whenever you send something, TCP tries to deliver it as much as it can. So when you use quality of service 0, again, we will see the example and you will understand where we have to use this parameter. So it means it's called at most once. So you trust totally on TCP. So in general, the MQTT will deliver your data, okay? Let me see, I see a question. Is there any downside to use hash to subscribe to as much as possible? Yes, clearly. Subscribing to hash, it can be a risky way to subscribe, because if your broker receives a lot of information from a lot of clients, you will start receiving a lot of information, okay? So it is reasonable, for example, to have a client subscribe to hash because, and this can be done for logging. So to have a client that logs all the messages, which is fine. If you have many clients doing like that, then the broker can get stuck because it has to retransmit everything to everyone. So that is not, I mean, would be problematic from the performance point of view. Okay, so going back, so quality of service 0 means at most once. I totally rely on TCP, and typically is the strategies used, the parameter used, because you trust on TCP. And okay, yeah, you can lose some message every now and then, but it's very, very rare. Quality of service 1 is when you want to be sure that at least once your message arrives. So, every now and then TCP can lose the packet because, for example, the acknowledgement is lost. So the sender sends again, so the receiver can receive twice the data. So it's very rare, but can happen. Okay. So if you set quality of service 1, you kind of guarantee that there is this the chance that you receive at least once. You may receive twice. And with quality of service 2, which is very rarely used, the protocol is here, so the steps are here. That takes longer. And you're basically sure that your data gets exactly once. And the definition is what you see here. So when you have to use this type of communication, when you want to ensure that non-idempotent messages can be delivered. What does it mean? So when you want to be sure that a message just gets one. Classical example is, imagine that you are controlling oven, okay? And you want to raise the temperature 10 degrees or 100 degrees. So you send a message, raise oven temperature, raise 100 degrees. So if that message gets twice, so the oven will increase the temperature to 100 degrees. So that will spoil your system, okay? So it's very rarely used, and typically quality of service 0 is, in normal deployment, is the right solution, okay? Okay, so we have brokers and clients, okay? These are the two elements. So brokers, the most widely used is Mosquito, okay? It's free, it has good performance. You can use it, I mean, later I will show you a demo with Docker, and it takes, again, 10 seconds to run a broker in your machine. It has a lot of information, it's widely used, code is available. It's a nice option. Then there is HiveMQ, which is also a very good implementation. The drawback is that if you want to use it with more than a certain number of connections, you have to pay, okay? Then there are others. Here you can see some RabbitMQ, ActiveMQ, and here you can find a list of other possible brokers. There are interesting projects like this one, Cloud MQTT. This is even the minimum requirement is you have to pay. And these are cloud brokers. So it's a broker that is available on the cloud. This other one is also interesting. This is free up to a certain number of connection. Then you have to pay. But for certain services, for a certain size of application can be used. And it already implements 5.0, MQTT 5.0. And then there are we will use some of them, which are called open brokers or sandboxes. So as the name indicates, they are used basically for testing, just trying out your application, okay? So these are available. You see here the name. We'll use some of them. We'll use basically this one. And in these web pages, you can find more information about the work. Port number standard is 1883, and the 8883 is the one based on TLS, so the encrypted TCP. You also have these sandboxes available for WebSocket applications, and the port is typically 8000 or 8080. And here you have a list of other public brokers. Clients. Well, there are clients for many different types of devices. These are for iPhone. These are for Android. These are online WebSocket. Online MQTT WebSockets. Just to try and play with them. Now, what we will use is this application that there is a version for any type of operating system, and we will use Python to write client written in Python, and at the end I will show you the equivalent code for MicroPython, so you can run a client on your PyPy or PyCom devices. Okay, so now I switch to this link. Okay, so let me move here, and here. So I think is so we are all here. So this is the data. I mean, the file that you see here are what you will find in the shared folder. So these are basic example. These two are for the when I create using Docker a broker, and this folder stores the files for MicroPython. Okay, I will use them. Okay, so but the first step is the first step is to use this tool, which is the one that you see here, MQTT Explorer. Okay, so when you install it, you will see something like this. Does each ESP that you need to run it, or can they share through one ESP that are maybe? No, I mean, every client, every device must have its own client. If what you think is about having a device that collects information from close-by sensor and then publish that information, that is something that you have to program yourself. But typically, each device will be a client if it has clearly internet connectivity. Otherwise, you have to create kind of a gateway element that is connected to the internet and that gets the data from the sensor from the other side. So this can be an alternative. Okay, so if I don't know if you have installed this application, this is very, I mean, as I said, there is a version for every platform. And for the moment, we will work with public broker, those sandboxes. They are here. And so the basic idea, what you have to do is click here, and it will open a new connection. I already prepared this one, and this one is with you. Here you can put the name that you want. This is, for example, HiveMQ. The protocol is either MQTT or WebSocket. We will use MQTT. Here you have to put the host address. In this case, we are using broker HiveMQ.com. The port is the standard one. You don't need username as password. And once you inserted those values, you can go to advanced. Okay. So in advanced, here you have where you put your subscription. In this case, we are working as a subscriber, consumer, a device that gets the data. So for example, what you have to do is basically write here test/hash. So what I'm looking for all messages that starts with test and then as any type of field. So you click on add, then it's here, okay? You go back, and then you connect, okay? So you should see something like this, okay? Here is also in this slide. So, and if you go here, you see there is people sending data of any type, okay? Because again, this is a sandbox, this is a broker that is used by anyone, and using as a first field test is kind of, classical way to test something, no? So you see here, people is producing information with many different topics. For example, there is this test Yasin lamp, and this, you can even see the history of this. You can see the test out. These are data produced by, I don't know who. This is, I'm sure, Italian because it's written in Italian, but they can be anywhere, okay? So again, so the question where all this data is coming from is, I don't know, it's some publisher that is producing the data, and my broker is collecting that information. And since I subscribe to test/hash, I'm receiving the information. So I think this is already a nice way to see the power of MQTT. So now let's, what I will do if there is someone doing the same with me. So if now I go to advanced, I delete this, and I add a subscription to, for example, Spain, Valencia, and UPV. Remember, uppercase and lowercase is important. So I add this, okay, and then go back. So I subscribe to that topic, okay? Okay, so I'm here, and at the moment, so the topic is very specific. Probably no one of you is trying to sense anything. So now I'm subscribed, but I can also publish. So what I have to do is I have to put here the topic I want to publish. Okay. Then, for example, I'll say raw. I could use XML or JSON. For simplify, say raw and say, okay. Okay. So if now to publish, so I publish. So since I'm also a subscriber, I receive the message. But if any of you subscribe to that topic, dependently from where you are connected, you will have received this message. Okay. So if any one of you is following, you can try and send messages, and that message will appear here. Okay. So what happens? So here there are a couple of quick questions. Okay. What happens if you type this label? So as you see, what I change is put everything in lowercase. Okay. So if I use this and I publish with this topic, okay, let's say hi. Okay, I publish, but I don't receive it. Okay, because I subscribe to capital S Spain, capital V Valencia, and UPV all capital. Okay, so be careful on that type. And the other quick test is very easy. So if you agree with a group of friends on a specific topic, and then you use this tool and you connect to the same broker, you can create kind of a messaging application where you can publish messages written here, and everyone in the group can receive those messages. And you will be using a shared broker and clients like the one I'm using here. Okay, so I think that can be a simple example of an application. Okay, so this is kind of a simple example. Let's do a more complex example. So now I want to collect data from a network server. Okay, so LoRaWAN, data goes to a network server. We already used if you check with the Docker class, you see that we were reading from sensors that were coming from a network server. I can do the same here. So the data I need is the broker address, which is this one, and this is given by TTN in this case, or whatever network servers you will be using. Be careful. TTN provides a MQTT broker. Not all network servers provide a MQTT broker. Okay, I'm using this case with TTN because TTN provides this type of broker. So, and TTN says, okay, you have to connect to this broker, to this address. The port is the standard, and you have to use this username and this password. Okay, which is what you see here. You have to copy and paste it. And the topic, again, TTN says that to get those data, this is the path, the topic structure that you have. So you see there is a plus here, which indicates the application, and the hash here to allow for all the data to get. Okay. So if we connect, okay. So, well, now we have to wait a little to for the data. Remember those sensors were producing data every minute, so we have to wait the production. So this is also important. Okay, even if those sensors, those publishers, are producing data continuously every minute, the way it works is that when the client sends the data to the broker, if the broker does not have any consumer, any subscriber at that moment, it will throw away the data. So the step is, I need to subscribe, and then from that moment on, the broker, whenever it receives data, it will forward the data to me. So you see, now I got the data, now there is a device, there is a client subscribed, and so now I got the data. Okay, so now I got the data that is coming from the TTN. Okay, so this is one device, and this is the other device. Okay, so this is important. This fact is important. So your client that works as a subscriber will start receiving data that is produced right after your client is subscribed, which means that the broker does not gives you the previous or the historical data. So those data, since you weren't subscribed at that time, is lost. So there is a question: how long time can it take from publisher to subscriber? Well, that depends. This is a TCP connection from a device to a broker, and from the broker to another TCP device. So it depends on the distance, and it depends on how loaded is the broker. I've done various tests and with clients and broker in the same continent, say in Europe, even with up to 100 clients, the performance is very quick. I mean, few tens of milliseconds, so very quick. Okay, so you see, we are using a generic client. We have to define which is the broker. We have to define which is the topic, and we subscribe. Okay, so, but this is kind of standard client. Okay, so let's now go with Python. Let's program in Python. Let's see how a client can be written in Python. Again, as I suggest in the slides, and you can either execute it online. There is this platform which is very useful. It allows you to execute the code in online, or you can execute in your computer. So you need to have Python 3 installed, and this PAHO library, which is the Python library to use MQTT. Okay, and it's basically a matter of executing this code. Okay. So This is the simplest subscriber. So you cannot do anything less than this. Okay. So let's see it here, and you have this file here, which is the csub. Okay. So it is the one here. Okay. So basically, the way it works is very simple. So you have to import the library, and the structure is here. Okay. So you basically define a client. Okay. This MQTT client. You can assign an ID, or you can leave it empty. Clean session means forget everything about the previous session, starts afresh. User data is used internally, not important right now. You have to specify the version. We will work with 3.1.1, and which protocol we will use below. It could be WebSocket or TCP. Then you have to use you have to set the username and the password. In this case, none and none means I'm not using those data, and you have to connect. Okay, the broker is this broker, and the port, and keep alive. So keep alive basically means how frequent the broker checks whether your client is still alive or not. It's just a way for the broker to see if it has to handle your client or not. And with this call, which is called loop forever, the library, the Power MQTT library, starts taking control of the process. This is a subscriber. So and messages can arrive to you at any moment. So it's not synchronous as HTTP, where you do a request and you receive a response. In this case, a publisher can publish at any moment, and a subscriber will receive whenever the publisher created the data. So you have to be prepared for the event of a message is arrived. So that's why we have to use what is called callback functions, where you have to say, okay, when the device connects, I want to execute this function. And when there is a message, I want to execute this function. In this case, whenever I do the connect, it prints out some parameter, and it takes the opportunity to subscribe to a topic. In this case, the topic is this one. Okay, and with quality of service 0. Whenever a on message event occurs, then it executes the on message, and basically it prints. So it prints the topic and the payload, and it's all embedded in this value. So there is a question, keep alive have to do with maintaining a TCP connection? Not exactly. It is a way for the broker to understand whether the client is still connected. Okay. So it's not to keep it alive, but to check whether that client is still alive. So imagine a situation where you have thousands of clients, and you want to be sure that they are still alive. So this mechanism allows the broker to understand whether you are alive or not. Okay, so this is the basic structure. So if I run it, see, so okay, well, it's not. Let's stop it right here. So So this is very, as you see, when you subscribe to hash, in this case is $6 hash, you start receiving a lot of information. So you see here, it says connected to Mosquito, which is here, Flex, which are here, and then you see all the message that we receive, okay? And I mean, there is a lot. The /hash is a lot of information. So you get byte received, client disconnected, client inactive. So a lot of information that is sent to you by the broker. But I mean, it's a way to check that this subscriber works. So now let's see the equivalent, okay, which is the publisher. And the publisher, again, you have it here. You can do cat cpub Okay, so here the structure is basically very similar. In this case, instead of onMessage, we have onPublish. And onPublish is the function that you have to call whenever you publish a message. The structure here is very similar. Okay, so what here instead of a loop forever, we use a loop start and loop stop. So this block is controlled by the PAO MQTT client, library. And what it does is, again, it creates a random integer just to simulate. Imagine that this instruction is substituted by reading the value of a sensor, okay, for example. And then it prints this message, and then it publishes that value. So you have to say the topic, which is right here, and the message, which we got it right here. We say quality of service 0 and retain, which, we don't have time to see it. So it waits 5 seconds and then again. So what we have to do is, if we do Python 3 5, so this will start producing information. Okay, so and it's using again this broker. So what if we want to see if the data are actually generated? So we can use the MQTT Explorer. We create a new connection, which is let's say testing, and the host is test.mosquito.org. And advanced, let's delete this and use the one we are interested. Okay, back, connect. Okay, so you see that now we are, you see now it's sending 26, 68. So we are, this client is receiving what we are sending, but the steps are sending the data. So this code in Python that is running here is sending the data to the broker, in this case testmosquito.org, and this explorer is subscribed to that broker and is receiving the data. Okay, so we are mixing a couple of code. So okay, so we can stop here. There is a question. There is some kind of lifecycle MQTT. No, I think, well, depends on what you think about lifecycle, but basically your clients start either producing data, publishing data, or start consuming data, subscribing and then consuming data. When you don't need to process those data, you stop your client and that's it. And when you don't want to provide those data, you stop producing those data. Okay, so I think it depends on the application. So, well, and there is a question, what should be modified in csoup.py? Well, if we go to csub, so basically what you have to check, and if you want, you can try it by yourself, is basically we are using the same broker. Okay, fine. The producer, the publisher is producing with this topic. So what we will have to do is use the same topic here and the system will work. Okay, so important, if you want publisher and subscriber to talk to each other, they have to deal with the same broker, fundamental, and they have to work on compatible topics. So if the producer produces something like this, you have to, for example, here say something like PM test. Sorry, I forgot that. Yeah. So you would have to say something like this. Okay. So if you modify the sysub like this, you see this topic is compatible with this topic that is used to produce the data, and so this client will start receiving. Okay. What if we want to repeat what I did before with MQTT Explorer to get data from TTN? Well, it's basically a matter of doing what I just told you. So basically and I have an example, you have an example in this folder. If you do if you look at this file, you will see that what I basically had to modify is the broker, which is the one that is indicated here, the topic, which is the one indicated, and the line that was empty and empty. You have to use the username, which is the one indicated here, and the password is this long token that is provided by the system. Okay. So if we run this code, okay, so it connects, and now again, as before, we are just subscribed, so we lost all the previous data. We have to wait for the following data to come, so that we will start receiving the information. Okay. So meanwhile, while we wait for data, there is a question. Keep alive is not related to birth, death, and last week. Yes, that's a different concept. I didn't want to talk about that part because I just have 1 hour. One of the way the broker uses the keep alive is, as I said, to determine whether a client is alive or not. And what it can do, if the clients properly configure the data during the connection, whenever the broker detects, you see here that I got the message, which are kind of, I received the whole JSON. There is another file here, which is the sysub ttn2, which kind of gets just the relevant information. You can check the code which is shared. So, as I was saying, if the broker determined that is not receiving the keep alive from a certain client, and that client specifically program the broker with what is called last will, the broker will publish a message on behalf of the client that is no more active, so that the subscriber can receive that kind of last will from that client that got disconnected. And that is a very useful kind of possibility, because it allows a system with thousands or tens of thousands of devices to always have the knowledge of which client is still active or not, okay, without having to check every time. So you see here, the difference between the two from one is that when I get the whole JSON, I take the information that I need. Okay, you can check the code and you will see that is basically a matter of going through the JSON file and take the information that you need. Okay, so a couple of final laps. So I talked a lot about clients. But okay, I want to create my own broker. Okay, well, and that's basically easy. You can either install it, but since you know something about Docker, you can do this Docker search MQTT and search MQTT, and you see there are many answers, but I think the first one is the one that interests us. This is the Mosquito open source broker. Okay, and so you have it here. This other one, MQTT client, is quite useful. It's another minimal MQTT client, but as you can see, there are many of them. So what we can do is run a broker in our machine. And I will do it with Docker Compose, okay? And the file, you have it here. You basically have two files here, Docker Compose YAML and MosquitoConf. MosquitoConf is a configuration file. As you can see here, is very minimal. So what it basically says that you allow users to connect without using username and password, and that you want to listen to port 1883, so very basic. And the Docker Compose is, well, you see it here. It's nicer to see it here. So it's a short version. So basically say, okay, version 3. So this server we want to run a Mosquito. We want to use this image, okay, the Eclipse Mosquito latest. We call it broker 1. We have to map the ports, again, for the same reason. We want the internal port of the container to be mapped to the port of your machine. And this configuration file, the mosquito.conf, has to be mapped with the mosquito config, mosquito.conf inside the container, okay? Because it needs the startup configuration. Mosquito.conf can be very complex and there's a lot of options, okay? So this is a very simple. So to start, Docker Compose, compose up. And so it pulls Mosquito and it creates. It says, okay, it's listening. It's listening on port 1883 and for IP version 4, IP version 6. This is a version running, and it's running. So if your host machine has an IP address which is accessible, as a public IP address. So now you have a Docker server, an MQTT broker available to whatever use you want, okay? So we can do it here. It's a very simple example. I do my connection, clearly it's local host. Okay, I can connect and, so in advance, by default, I'm connected to hash and $sys hash. So if I connect, so you see there is new client connected. As you see, the IP address is the one of the container. Again, at this moment, the IP address of my machine is blocked for my university rules. But if you do the same on a server that has a public IP address, okay, it will be available to anyone. And here you see all the information that I'm receiving. And again, I can use any broker, setting the broker address and the topic. Okay. Last but not least is, okay, this is Python. What if I want, for example, to use a client, MQTT client on a lobby, on a PyCon device. So I put here in the code MicroPython that code. So if you do code MicroPython, you see there are four files. The ufun is simply a library that I created with some function to simplify work. This one is the equivalent of the Pajo MQTT library. So this is the MQTT the code of the MQTT client for a PyCon device. And if you see it, it's kind of very, I don't remember if 130 lines. So you see, it's a very simple code and which can work on clients as simple as a PyCon, which is a ESP32 based device. Okay, so here you can read the code line by line. Okay, and this is the complete code of a client. Okay. So look at, if we take it here and then let's see. Okay, so this is a Python version of a subscriber, and this is the MicroPython version of a subscriber. As you can see, the structure is more or less similar. This is basically you have to assign the broker. In this case, you need to connect to the internet. So for the PyCom, I would use Wi-Fi. You have to define the callback function, like the onMessage, which is more or less equivalent. You see, kind of very similar. This function is a function that you can find the UFun package, which is simply to simplify the connectivity to Wi-Fi. And you see, here is the topic. Here is the let's say the client, the broker address, and the port. You define which callback function you have to call, the onMessage. You do a connect, okay, and then you subscribe, okay, which is like here and which is like here. And then this is the client loop forever. So you basically keep on waiting for messaging. So you can see is the code is very similar with this very basic limitation. So if you want to try with your PyCom, just go here, go to the code UP, and you will have the simple pub and simple sum. Basically, you will need a Wi-Fi access point, and you will have to put the SSID and the password here, okay? And then clearly adapt the broker address and then adapt the topic, but you will have a fully operative broker, a fully operative client. And that's it. So that is basically it. So I don't know, just around 1 hour, okay?
Yeah, it's around 1 hour. I did not bother you since you were going very smooth, and so and you also found all the questions. So
yes, I don't know if I missed any of the questions.
no, I think you answered all of them.
Okay.
And
so yeah, I think, well, in conclusion, I think it's the advantage of MQTT is it's lightweight, so it can work on, as I said, PyCom. The code is the one that I showed you, and the advantage is that you can have a lot of clients talking together, producing data, consuming data in a very easy way. And the broker, creating a broker is as easy as creating a client. As you saw in 10 seconds with the Docker, we created a broker in our machine.
Mm-hmm. Yeah, so with that, thank you for your contribution to this course.
Okay.
And we are looking forward to welcome you next year also.
Okay, yeah, sure. Be happy to come and happy to be part of this course. And again, as I said the other time, if any of those that are listening or watching this in the next days, if you have any question, there is my email address. Just send me an email.
Yeah, thank you.
Okay.
Thank you, Pietro.
Okay.
And,
bye.
Have a nice evening.
Thank you. You too.